Hi, this is Jeff Spencer, your statistics instructor for the Community College Denver. And this is a video now using the empirical rule, which I went over in the last video. And so in the last video, explained what a normal distribution is, what the rule is of the empirical rule, the 68, 95, 99.7 rule, and how from that rule we can break down the bell curve into this picture where you have all the percentages in between each standard deviation gap. So let's show how we can use this information from the last video for a particular example to answer these questions. So, so generally, when you do this problem, you're already going to have this picture set up, all right, with the percentages here. The 68, 95, 99.7 within 1, 2, and 3 standard deviations, and then the breakdowns with the 34 and the 34s, the 13.5s, the 2.35s, and the 0.15s. That's all from the last video. So let's look at an example on how we're going to use that picture and then add some to it to get our answers. So let me zoom in just a little bit here now and say, okay. So the distribution, let's say the distribution of the weight of a particular adult animal is normally distributed. That's a key term to tell us that it's bell-shaped, with a mean of 35.3 kilograms and a standard deviation of 1.4 kilograms. Use the empirical rule. So now we know that we're using, since it's normally distributed and we're using this empirical rule, we're using this picture and the breakdowns to answer the following questions. So before we get anywhere, we need to basically mark off what the mean is, what the weight 1 standard deviation, 2, and 3 standard deviations is, and what the weight 1 standard deviation below, 2 below, and 3 below is. So I've already started by putting the mean, the 35.3 kilograms, in the middle, and then I'm going to mark the weights that are 1, 2, and 3 standard deviations above the mean. So the standard deviation is 1.4, so I'm just doing 35.3 plus 1.4. 36.7. So 36.7 is the weight that's 1 standard deviation above the mean. And then I just add 1.4 again. So plus 1.4, 38.1. Add 1.4 again, 38.1 plus 1.4, 39.5. So now I have the weights that are 1, 2, and 3 standard deviations above the mean. Now I'm gonna do the weights that are 1, 2, and 3 standard deviations below the mean. Let's see, yeah, this is gonna be a little bit of a formatting work here, so give me a second. Okay. All right. So this is going to take me a second, but either way, okay. So 35 points. So find the weight that's 1 standard deviation below. I do 35.3 minus 1.4. That's 33.9. Oops, 0.9. Okay, let me fix that. Normally you'd be writing this, it's a little hard to do it in the computer. Okay, and then to find the weight that's 2 standard deviations below, I subtract 1.4 again. 32.5. Okay, just adjusting this so it looks lined up. And then the weight that is 3 standard deviations below the mean, I'm going to do right here. So take the 32.5 minus 1.4 again. 31.1. All right, so now I got all my weights here that line up with the values of 1, 2, 3 standard deviations below and 1, 2, 3 standard deviations above. Now that I have this all set up, now I can pretty simply answer these questions. So this one says 68% of these animals are between what 2 heights? Well, 68 is the percentage above within 1 standard deviation. So I can just look at the weight here and the weight here, and that's my answer. So 33.9 and 36.7% of the animals are between what 2 heights? These are the weights, excuse me. So 33.9 and 36.7 kilograms. Okay, next, what percent of these animals weigh above 36.7 kilograms? Well, 37.66 kilograms is 1 standard deviation above. So to do this, to figure out the percent above, all I need to do is look at the percentages above, the 13.5, the 2.35, and the 0.15, and just add them. So it's 13.5 plus 2.35 plus 0.15. I could show you that in a calculator, but I already know what it is. It's 16%. Okay, next. What percent of these animals weigh between 31.1 and 38.1 kilograms? So 31.1 is right here on this line, 3 standard deviations below, and 38.1 is 2 standard deviations above. So really what I need to do is just line that up correctly. Then I'm finding the percentages below, or sorry, between those two weights. So I'm adding this, this, and this. So I'm starting with the 2.35, adding the 13.5, I'm adding two 34s, I'm adding a 13.5, and that gets me at the 38.1. All the percentages that I've shown here are between those two weights. So let me add those up. 2.35 plus 13.5. The 34s, the two 34s are 68, so I'm just going to do plus 68 plus 13.5, 97.35%. All right. Next. And so really what's cool about this with the breakdowns, you can add, really these last two problems show that I can find the percent above, below, or between any two values by just finding the percents in the breakdown and adding them up. That's a key thing here. Okay, now when we use this term percentile rank, don't forget we talked about percentile rank in a previous video. The percentile rank for any value is the percent below or equal to that value. More specifically, the percentile rank for any value is the percent of the population that is below or equal to that value. So what I got to do in the bell curve situation is if I have 33.9 kilograms, I'm really just looking at the percent below or equal to that value. Now the or equal to part is kind of misleading, I guess, because there's no percent equal to 33.9 because it's right at 33.9. It's like a number with 0% as a line. So we're just basically, when we see percentile rank, think percent below. Okay, so I'm just adding the percentages below 33.9, 13.5, 2.35, 0.15. I've done that before right here. It's the 13.5. These three percentages happens to be a coincidence that it's the same numbers. It's the percent below 33.9 is those three numbers. I add them up, I get 16%. You can also call it the 16th percentile if you like. I'll accept either answer. Okay. 99.7% of these animals are between what two weights? So I look at the 99.7 is one of the three numbers from the empirical rule. 99.7 is 3 standard deviations below to 3 standard deviations above. So I just look at those values, 31.1 and 39.5. 31.1 and let me see, 39.5 kilograms. Okay, the last one, what is the percentile rank for an animal that weighs 38.1? Well, as we said, percentile rank is percent below. So I'm just going to look up 38.1 and add all these percentages below, right? So I could do that. I could add all of these percentages below. That's one way to do it. Or another way to do it is I look at it as I say, well, why don't I just add these two percentages above it and then subtract that from 100? So there's two methods to do it. I'll show both here. So 13.5 plus, so now I'm doing all the percentages below, this plus this plus this, all to the left. 13.5 plus 34 plus 34 plus another 13.5 plus 2.35, I'm sorry, plus 2.35 plus 0.15. Add all that up and I get 97.5%. Or another way to do it is to add the percentages above, just because there's a lot of percentages below, it's just easier to add these two numbers. So I could do 2.35 plus 0.15. That's 2.5%. Then do 100 minus 2.5%. And voila, guess what? It's the same answer because it's two different methods to get the same answer. Or you could say the 97th 97.5th percentile. Usually percentiles are rounded to the nearest whole number. However, since we have this answer exactly, we're just going to give it like that. I'll take either answer in either form, but it's 97.5 is the number. All right, that's it for these examples, and we will see you next time.